Imagine living in a habitat that feels like Mars. Every decision you make matters, every resource is precious, and just outside your door is a vast, frozen wilderness. Your only link to the outside world is a delayed communication line to mission control, and your survival depends entirely on your team. This isn't science fiction. It's an analog mission simulation right here on Earth that prepares us for life beyond our home planet. Welcome to the world of the Analog Research Group, or ARG. We are created to transform learning into a living, breathing experience. Instead of just reading about space missions in a textbook, AARG gives students at the American Public University System the incredible chance to step into the boots of an astronaut. These missions happen in special habitats designed to mimic the exact conditions of space exploration. We're talking remote, confined, and resource-limited environments where resilience and innovation aren't just buzzwords. They're essential for survival. Inside these habitats, students don't just study science. They become scientists, engineers, and explorers. They work together as a crew, solving real problems under intense pressure, just like the astronauts aboard the International Space Station or future explorers on Mars. One day, you might be planning an extravehicular activity, or EVA, in sub-zero temperatures, using a drone to navigate snow-covered terrain and map your route. The next, you could be managing the life support systems, carefully monitoring spirulina growth for oxygen production, or troubleshooting a 20-minute communication delay with mission control. These aren't hypothetical exercises. They are real, complex tasks that mirror the intricate dance of space operations. So, how exactly do these analog missions mirror real space exploration? It's all about replicating the constraints. Think of them as scaled-down versions of actual missions, designed to test both technology and human spirit. First, there's the isolation and confinement. Crews live in small habitats for extended periods, simulating the intense psychological stressors that astronauts experience on long-duration flights to the ISS or, one day, to Mars. This tests teamwork, conflict resolution, and mental fortitude in ways a classroom never could. Then there's resource management. In space, every drop of water and every watt of power is critical. Analog crews operate under the same strict limits. They have to carefully manage their food, water, and energy supplies, learning to conserve, recycle, and innovate. This isn't just about following rules. It's about developing a deep, instinctual understanding of sustainability in a closed-loop system, a skill that's becoming increasingly vital both in space and here on Earth. Let's talk about EVA operations, or spacewalks. EVAs are some of the most complex and risky parts of any space mission. Our analog missions simulate these spacewalks in some of Earth's harshest environments: snow, ice, or blistering deserts. Crews test everything from suit mobility and life support packs to communication protocols and navigation techniques. Imagine putting on a full analog suit and stepping out into a landscape that feels truly alien, knowing your every move is being monitored and analyzed to make future spacewalks safer and more efficient. And what about communication? When astronauts are on Mars, they'll face a communication delay with Earth of up to 20 minutes each way. You can't just have a quick chat with mission control. Every message has to be clear, concise, and structured. Our analog missions use systems like ECHO to simulate these delays, forcing crews to plan ahead, communicate with precision, and operate with a higher degree of autonomy. It's a fundamental shift in how a team operates, and it's something you can only truly learn through experience. Safety is paramount in space, and it's paramount in our missions too. NASA uses sophisticated models like space flight resource management and continuous risk management to keep astronauts safe. We adopt these very same frameworks. Our crews are trained to constantly identify potential hazards, manage risks, and respond effectively to emergencies. This creates a culture of safety and preparedness that is the bedrock of all successful spaceflight operations. Finally, it's all about the science. Just like astronauts conduct experiments on the ISS that push the boundaries of human knowledge, our analog crews perform real, valuable scientific research. They test new methods for plant growth in confined spaces, develop water remediation technologies, and study human psychological and physiological responses to extreme environments. The data collected on these missions contributes to a growing body of knowledge that helps space agencies plan for the future. So, why does any of this matter for your career? Because the space industry is looking for a new kind of professional. Space agencies and private companies aren't just looking for people with good grades. They're looking for individuals who can think critically under pressure, adapt quickly to a changing situation, and lead effectively in unpredictable environments. An analog mission teaches you those exact skills. It prepares you for a huge range of careers, from planetary science and aerospace engineering to mission planning and even science communication and outreach. When you complete an AARG mission, you don't just get a certificate. You get tangible, hands-on experience that makes you stand out in a highly competitive field. Imagine being in a job interview and being able to talk about the time you used a real EV suit to simulate a walk on a Titan-like moon, or how you applied NASA's own safety models to reduce human error during a simulated emergency. You'll have contributed to research that could genuinely influence future missions to Mars or the icy moons of Jupiter. You'll have created outreach tools that will inspire the next generation of explorers. This isn't just another program. It's a gateway to the future of space exploration. It's a chance to be part of something bigger than yourself. And that journey continues with our next mission, EVAs. We're heading to Concordia University's incredible BioHouse facility in Minnesota's frozen wilderness. There, we'll be testing new EVA systems in an environment that mimics the icy, challenging terrain of a moon like Titan. It has an opportunity to push the limits of what's possible and to contribute to the next great leap in human exploration. If you've ever dreamed of going to space, of being part of the team that gets us there, this is your first step. This is how you go from dreaming to doing. Thanks for watching. Be sure to subscribe for more updates from our missions and to follow our journey as we prepare for humanity's future in space.